Hello, and welcome to this demonstration of the CAD Enhanced Schematic Checker tool. The Schematic Checker aids Allegro HDL schematic designers by providing a lightning-fast method to find logical connectivity problems before the packaging step. At CAD Enhance, we ask the question, why would you want to package a design that is improperly connected to start with? It cross-checks connectivity in the flat or hierarchical designs, keying on off pages to get signal and type information. For best performance, CAD Enhance recommends that designers use the predefined input, output, and bidirectional off pages to connect signals across pages. For example, input pages and output off pages. We also recommend that hierarchical blocks get drawn with their I/O ports on only one page, separate from the rest of the block, and that the I/O ports are connected with off pages to the other pages. For example here, these are only in ports, which are hierarchical blocks, and they go to off pages which connect to the rest of the block. These are out ports, and they're connected with input off pages. The benefit of this method are threefold. Connectivity is fully checked and contained within the block in this case. It also allows the designer to easily move between a hierarchical design and a flat one. To do that, you would just get rid of page 2 in that block. And thirdly, it allows the schematic tool to automatically build a symbol for that block using the layout of those I/O ports, which is extremely powerful when you're doing hierarchical design. As a matter of fact, so we can draw this block and we order the inputs and outputs and bidirectionals by their placement on the page down below, and Cadence cannot do that. The schematic check tool operates outside of Allegro HDL, requiring no license from Allegro. It reads all of its information from the .CSA and .CSV ASCII text files that are generated when a schematic is edited. While it runs outside of Allegro, it can be started from within Allegro, and it creates Allegro HDL compatible marker files that can be used to navigate to the errors found by the tool. Let's take a look at the schematic checker at work. We start the schematic checker using the Allegro HDL CAD Enhance menu and select the schChk button. It pops up this menu. It's a GUI which lets us select any of the hierarchical blocks. Now this is a medium complexity design with 13 hierarchical blocks in it. If we were doing a flat design, it would really only have the top, the top block. With this button we can select all the blocks, we can clear all the blocks and individually select the ones that we want to check. And then in this case we want to select all, and then we have the check schematic button. So we run the check, and it is running very quickly, running through all the ASCII files, much faster than the Cadence cross-referencer does. And it's finished right now. It showed us all the results here. So these 7 blocks are green, and these 1, 2, 3, 4, 5, 6 blocks are red. So those are blocks that we detected errors in. For each one of the red blocks, there's a tab which shows you the errors that were found. So in this block, we had the GN1406 block. We had one unconnected input off page, and we had one unconnected output off page. And these are the details of where they might be. In the MC block, we had a handful more of errors. So we had some multiple driver output pages. We had 2 unconnected output pages, and we had 5 unconnected input off pages. And then we can go through the blocks and see that we had several there. So it used to be we would use these to go make the corrections because there is enough information to go find. We know what block we're in, GN1046. At page 1 we have a problem. So out 0 P1 at coordinate minus 3300 2425 is not driven, and one output off page on page 2 has no loads. That one should be easy, so we just have a name mismatch. The other thing that happened when we ran this tool is we created the marker file that we discussed. So we're going to go open that up, Tools, Markers, load, and we're going to open a fresh copy. It's in CAD Enhance schChk marker. We'll open that up, and it tells us that it sees 28 errors, and it's all the errors. It's a summary of all the errors for all the blocks that we saw. So for every single one of these errors, there's a tick in here. Okay, so we could put this away, and now we can start navigating through the design to go find the errors. So again, that first error we saw, let's close this width a little bit so we can see what's going on. So if we click it, we can see the black square pop up and show us where we are. So we have unconnected out 0 P1 here, and we have unconnected output out 0 P, and let's zoom back a little. So we can see that out 0 P1 looks wrong. Everybody else is out 0 P, out 0 N, out 1 P, out 1 N. So let's go back to that one, zoom on it, and take a look. And let's go. So we're going to change that name using the Allegro tool, and we'll save it. And that should clear those two errors. So now we're going to jump into the MC block. So here we have the multiple driver errors. And multiple drivers, we can see multiple driver for MC R80J. So this is the signal name, P21 at MC block P4, 3350, 3825, and we also have the same one at 3350, 3775. So if I zoom out a little on this one, it's going to become clear what the error is. We did a little cut and paste problem. So we have 23, 22, 21, we're skipping 20. And if we look further in the design, we're going to see that 20 is unconnected. So let's go back to the one that we see. So we should see 23, 22, 21, and let's zoom out a little more and see that we're connecting to the FPGA, and P20 is connected to P21. So let's fix that. P20. Save. And then let's look at this one. We have the same kind of problem. We have MC far at 3400. We have MCR far on page 5, 3400, 2750. And let's zoom out on this one a little bit. So what we want to see is what the names are, and are they making sense. So that's one, and they all look pretty logical. And then let's jump to this one and zoom out. So that's on the bottom of the page. And what do we have there? So we have MCL, 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 MCR far. So the L and the R got swapped. And if I slide back, we can see that it's supposed to be an L coming from the FPGA. So we'll fix that. When we fix these multi-driver errors, we're also going to be fixing the input errors. So now let's look at this. Multiple drivers for M10, A110 at 623. So again, let's zoom out, and we can see right away that these are all M01. If I slide back a little, they should all be M01, and therefore I should fix that. And we'll go change M01, and then let's save that. Okay, and then let's jump over here to this unconnected output, SCR. This is on page MC block page 7 of that coordinate, and jump out a little bit and look at that. This happens to me a lot when you get into the change mode in Allegro, and you forget you're in the change mode, and you accidentally type something in front of a signal or at the end of a signal. So we can see we have extra characters there. So let's change that. Okay, so now we just made a bunch of fixes, and I'm not going to fix them all. I'm just going to show you how my methodology. So we had 28 errors. We're going to close this. We're going to rerun the tool, and it's still open. So let's check the schematic again. It restarts. Notice that the GN1406 block is now clean. We have 1, 2, 3, 4, 5, 6, 7 blocks, and we have 1, 2, 3, 4. So the MC block still has a couple errors, but it's only 2 now. And we further. So the typical operation of this is we just go through each one of these guys, and then let's go back to the marker file and see that. But the typical operation is we interact with these errors and we go fix them. And we're going to load, open, CAD Enhance, schematic check, marker, open, load it up. Now there's 14 errors, and we can see the problems here on these pages. So unconnected output R80J minus, and we would go handle this the way we normally do. And I don't want to finish cleaning up to waste your time here. So I just want to say you can see how efficient this tool is and how quickly you can go through a design and fix things up. There's 2 modes of operation usually. When I'm designing a block, I would do one block at a time. I would clean up those errors before I go on to my next block. But you can also do it from the top level and do every block at all. So again, if we start the checker and we just want to see the errors in the MC block, we'll clear all, do that, we'll check it, and we end up with 1 error, and these are the 2 errors in that block. So I thank you very much for listening. You can go to www.cadenhance.com to learn more about this tool, and thank you for your time.